Explicit and recursive formulas from tables and patterns. So we've done explicit and recursive formulas before in Math 1, Math 2, and we're going to look at it again in Math 3. So recall that I think Math 1 you use the function notation when you're working with your um, recursive and explicit notations, but in Math 2 we start to use the subscripts A sub 1, sub 2, sub 3, and so that's what we're going to use. Remember the A sub 1 it stands for the first term. This is the second, third, and of course this stands for previous term, and A sub n is the nth term. So make sure when you're writing these out that they are subscripts, so they should be lower than the variable that you're using. So recall, we have the explicit form. So the explicit form of an equation where n represents the stage slash term number for a pattern where you do not need the previous term to get to the next term. You can plug in the number into the equation and get the term solution you are looking for. So a lot of times explicit form is the easiest to use. So to find the explicit patterns, we're going to be using our calculator, and these are the steps. So we're going to use our calculator step plot and either be doing linear regression, quadratic, or exponential. We'll talk about those steps in a little bit. Recursive form. For this one, recall that it defines the terms in a pattern by using the previous term slash stage number. Remember, there are two things that you have to list when you are writing the recursive form. So step one is to state or define the first term of the pattern, because if you need the previous term to get to the next term, and again, remember the previous term is a to the sub n minus 1, that means you need to know where you start. So that is the first part of the formula that you need to state. The second step says write a formula for the nth term of the pattern. So for this, you're going to have a sub n equals whatever the previous term is, a sub n minus 1 plus something. So that something depends on if you are, working with linear or quadratic. And keep in mind that you have to use or write down both of these when you're writing your recursive form. And also remember that we do not use negative subscripts. So keep that in mind, that the subscripts are always going to be positive. Okay, so let's go ahead and look at some examples. For the first table, if we want to find the pattern, remember that we want to look at the difference between, each of the terms. So if I subtract the terms, 3 minus 1, that's equal to 2. 5 minus 3 equals 2. 7 minus 5 equals 2, and so on. 9 minus 7, 11 minus 9, 13 minus 11. And so because the first difference, because it's the first time we subtract, is the same, that means that this is a linear pattern. And so recall something that is linear uses the form y equals ax plus b. So you could, find this by using your slope and then picking a point and plugging it in. But we can also use our calculator to help us, which sometimes is a little bit faster. So let's go ahead and practice that since we haven't yet. So if I want to plug this into my calculator, first of all, you're going to go to your stat plot. So go to stat and enter on edit. If you have anything in your list from previous time, you can go up and highlight and hit clear and push down. Or you could just hit delete on the actual number. Remember, don't do that on the list because it'll delete the list. So in list 1 goes your n value. So 1, 2, 3, 4, 5, 6, and 7. And in list 2 is the nth term, so the a sub n. 1, 3, 5, 7, 9, 11, and 13. So make sure you also practice plugging this into your calculator so you can practice the steps as we go along. It'll help you when you're doing it on your own. So if you need to pause the video to do so, make sure you go ahead and do that. And it looks like I missed a number, so I need to go back up. We have 1, 3, 5, 7, 9, 11. Oops, I just didn't hit enter. Okay, 13. So the next step would be to hit stat, and we're calculating. We know that we're doing linear regression since that is a linear pattern. And then we're in list 1 and list 2. If you're not, to get list 1 and list 2 would be second 2 and list 1 is second 1. And then scroll down to calculate, enter. And we get an a value of 2 and a b value of -1. So we got a is equal to 2 and b equals -1. So we don't use y and a or x, we need to use our notation. So a sub n is equal to, in this case we would have 2, and instead of using x we're using n, so 2n minus 1. And that is our explicit form. And remember, we like this form because I can find any term in my equation by plugging it in. So let's say I wanted to find the eighth term. That would be a sub 8. So that means I'm plugging 8 into my equation for n. So 2 times 8 minus 1. So a sub 8 is equal to 2 times 8, which is 16, minus 1. So that means that our eighth term is equal to 15, which we could have done very easily by, just adding 2 to the 13 here. But this is helpful for when you get to values that are a lot higher. So like, let's say you wanted to find the 100th term, plugging in would be a lot easier. So the next thing we're going to go ahead and look at is the recursive form. So for the recursive form, remember that the first thing you need to do is state the first term, because in order to get to the next term, you need to know the previous term. So our first term, I always like to start off with a sub 1 if I can. So a sub 1 is equal to 1. Then we need a formula for the nth term. So a sub n is equal to the previous term. Remember, that's this notation. And then what are we doing with the previous term? Well, the slope, of course, is 2, so that means we are adding 2 each time. So that is my recursive form. And so recursive form is different, and there are some equations where we can only use recursive and can't use explicit. So that's why we need to know it. But for this, let's say I wanted to find the eighth term using recursive form. So if I wanted to find the eighth term using recursive, if I plug 8 into this equation here, I would get a to the n, which is 8, because we're saying this is n equals 8. Same thing what we did up here. N was equal to 8. We plugged it in. So 8 minus 1 plus 2. So for this, a sub 8 is equal to 8 minus 1 is a sub 7 plus 2. Well, had we not already from the table had the seventh term, then we couldn't actually answer this equation until we had the seventh term. So that's why for this one, you have to know the previous term to get to the next term. So a sub 8 is equal to, well, what is the seventh term? You can see from your table, a sub 7 is 13 plus 2, and that equals 15, so that checks our work. But again, you would need to know the term that comes before it in order to get to that term, which is why it's called recursive. So why don't you go ahead and do this next one on your own. When you're done, you can unpause the video and we'll check our work. So for this one, when you subtract, the difference for each of these you should get is 3, which means this pattern is linear. And so the explicit form, again, when you plug it into your calculator, you get a sub n is equal to 3n plus 4. And for the recursive form, and again, even though it has a 0 term, I'm going to go ahead and start with the first term. It just makes it easier. So a sub 1 is equal to 7, and a sub n is equal to the previous term. And what are we doing with the previous term each time? We are adding 3. So the previous term plus the common difference, and the common difference again was 3 for each of the terms. Okay, so for the next one, let's go ahead and do the same thing. So we want to first look at our differences. So that means that first thing I'm going to do is go ahead and subtract. So 9 minus 3, which gives us 6. And 19 minus 9, which is 10. And then we have 33 minus 19, which is 14. The next one we would get 18, and the next one we subtract, we get 22. So again, you're just subtracting each term. So these are not the same. The first difference is not all the same number. So let's go ahead and subtract again. So 10 minus the 6 gives me 4. 14 minus 10 is 4. 18 minus 14 is 4. 22 minus 18 is 4. So that means the second difference is the same, which means this pattern is quadratic. So recall for quadratic, we have y equals ax squared plus bx plus c. So for explicit form, again, we can use our calculator and plug it in. So you go to your stat and enter on edit, and I'm going to clear out list 2 and list 1. Again, remember if you accidentally up here hit delete, it deletes the list. So you'd have to enter it back in by doing second delete, which inserts, and then second 1, which is list 1. So keep that in mind. So let's go ahead and enter those values. And so you guys should enter into your calculator as well. So we have 1, and then 2, 3, 4, 5, 6, and then in list 2, 3, 9, 19, 33, 51, and 73. Stat, and then you're going to go right arrow to calculate. Now we're not doing linear, but quadratic, so number 5, and then go all the way down. Make sure you're in list 1 and list 2. Enter, and here's our A, our B, and our C. So 2 is for A, B is 0, and C is 1. So A equals 2, B equals 0, C equals 1. Again, we don't want to use this notation. We want to use our notation for recursive and explicit form. So A sub n is equal to 2n squared. We don't need to write plus 0x, so we can leave that out. So C is 1, so plus 1. That is our explicit form. Now we need a recursive form. So this one's a little bit harder. So for recursive form, a sub 1 is equal to, so our first term is 3. So again, that's from our table right here. So then how do we get to the next term from our previous term? So a sub n is equal to our previous term plus, and what did we do? So in order to get that, you always are going to add your second difference, which is 4. So 4 times n plus something. So how do we get that something? Where does that come from? It comes from using our table over here to kind of help us. So for this, we're going to go ahead and plug it in. So let's go ahead and we start off with 1. Let's go ahead and use an n value of 2. So I'm going to do my work over here. I'm going to use a different color. So if we do an n equals to 2, we're going to be solving for this box using our table to help us. So a sub 2 is equal to, and we're plugging in 2 in for all our n values into our equation. So 2 minus 1 plus 4 times 2 plus something. So then we're just going to simplify this here. And I'm going to do it right here because I'm running out of room. A sub 2 is equal to 2 minus 1 is just 1, plus 4 times 2 gives me 8, plus something, and this is where your table comes in handy. So your second term from your table, this is your a sub n column, is 2, or excuse me, is 9. And a sub 1 from our table and from what we wrote over here is equal to 3 plus 8 plus something. So I'm going to go over here. So now we have 9 equals 11 plus something. And so now to solve for that something, I can subtract the 11, and I get negative 2 equals that something. So if I plug negative 2 in here, that should be my recursive form. So we can check our work. So I'm going to check my work by using a different color. Let's use blue. And for this, we're going to do the third term to check our work. So I'm going to check. So a sub 3 is equal to a sub 3 minus 1 plus 4 times 3, and then plus negative 2 or minus 2 is the same thing. We're checking it by using the third n equals 3, third term. So a sub 3 is equal to 3 minus 1 is 2 plus 12 minus 2. We're going to use our table to help us. The third term, a sub 3 is 19. So that should be equal to the second term plus 12 minus 2. The second term, again, if we go to our table from the last one that we did, is 9 plus, and 12 minus 2 is 10. So 19 equals 19, so it checks out. So again, that last part was just checking the work that I have. And so that means that this is the correct recursive form. Of course, you don't have to write plus negative 2. You could just write minus 2, same thing. So go ahead and do this example on your own. Pause the video, and then when you're done, you can unpause it to check your work. So for each of these, when you do the first difference, you get negative 9, negative 3, 3, 9, and 15. Because remember, 26 minus 11, 11 minus 2, 2 minus negative 1 minus 2, and 2 minus 11. And then when you subtract again, you get 6. So that means this is a second difference, so the pattern is quadratic. And we need the explicit form. So a sub n is equal to, so plug this into your calculator, do stats, calculate, and we want quadratic. So this would be 3n squared minus 1 is what you should have gotten. For the recursive form, we know that our first term, we can't use negative subscripts, and I don't usually start with 0. You like to start with 1, so I'm going to go ahead and use this as my first term. So my first term is equal to 2, and my nth term is equal to my previous term, and my second difference was 6, so plus 6 times something plus something. So we need to find that something. So how do we find that something? We're going to start off with n equals 2 to help us. So when n equals 2, I have a, and I'm plugging 2 in for all 3 of these n's. So a sub 2 is equal to a sub 2 minus 1 plus 6 times 2 plus something. So we're going to use our table to help us, but I'm going to simplify this first. A sub 2 equals 2 minus 1 is 1, so a sub 1. 6 times 2 is 12, plus something. So the second term from my table, I get 11. So I'm just taking that a sub 2 out and plugging 11 in because I know they're equal. A sub 1 from my table and from what we wrote over here is equal to 2. And so we have 11 equals 14 plus something. Subtract the 14. And we get negative 3 is equal to that something. So that means over here that something is minus 3. And so we can check our work again by using the third term. So we could do n equals 3 to check our work. A sub 3 equals a sub 3 minus 1 plus 6 times 3 minus 3. A sub 3 equals 3 minus 1 is 2 plus 6 times 3 minus 3. And so our third term we know from our table is 26. Our second term from our table is 11. I guess I could have done the 18 minus 3. So I'll just go ahead and put the 15 here. And so 26 should be equal to 11 plus 15 is 26. And so it checks out. So we just checked our work. And that's it for the quadratic. Let's go ahead and move on to the next. So for this next one, go ahead and start subtracting to find the differences. So when we do that, 6 minus 3 is 3. 12 minus 6 is 6. 24 minus 12 is 12. This gives me 24. And 96 minus 48 is 48. So if I do that again, you're going to be looking at the same numbers. Notice I have 3, 3. Oops. Notice I have 3, 3, 6, 6, 12. So if I subtract again, 6 minus 3 is 3. 12 minus 6 is 6. 24 minus 12 gives me 12. And 48 minus 24 is 24. And then again, if I keep doing it, keep notice I keep getting the same numbers over and over. So that means for this, that this is neither linear nor quadratic. So we're going to go ahead and erase all of this. So it's not linear or quadratic. So that means we want to check exponential. So to check exponential, you divide your terms. So it's, of course, the next term divided by the previous term. So in this case, we're dividing 6 over 3, which gives me 2. And for this one, we would divide 12 over 6, which is also 2. 24 over 12 equals 2. 48 over 24 equals 2. And 96 divided by 48 also equals 2. That means this is exponential. So then I want to find the explicit form, and again, I can use my calculator. So if I go to my calculator, stat, enter on edit, I'm going to clear out these lists and down, or again on the list you could hit delete, just not when you highlight the list. So for this one, I guess I could have left the list 1 in there. And in list 2, 3, 6, 12, 24, 48, and 96. Oops. And then stat, right over to calculate. Now we're doing exponential. So if you keep scrolling down, you'll notice you have exponential regression. So EXP REG. And then make sure you list 1 and list 2, enter. So notice that we have an exponential equation, y equals ab to the x. We've talked about that in the last unit and in Math 1 for our exponential equations. So your a value is 1.5 and b is 2. So recall exponential, y equals a times b to the power of x. So we just said that a was equal to 1.5, b was equal to 2. So we have to use our correct form. A sub n is equal to my 1.5, so my a value, times 2 to the power of n. And the recursive form, again, you have to state the first term. So we're using a sub 1 is equal to 3. and the nth term is equal to the previous term. And what did we do with the previous term? So now we are not adding something or subtracting something, we're multiplying, right? So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24, etc. So all of this is being multiplied by 2. So go ahead and do this next one on your own. So pause the video. When you're done, you can unpause to check your work. So for this one, when you divide each term, 18 divided by 6 is 3. 54 divided by 18 is 3, etc. for each of them. So that means the pattern is exponential. And the explicit form, when you plug it into your calculator, a sub n equals 2 times 3 to the power of n. Recursive, your first term is 6, and your nth term equals the previous term, and times your common ratio is what that's called when you divide it each time. All right, so the next one in 2, it says write the recursive and explicit form of each pattern below. So go ahead and pause the video and see if you can do these on your own. When you're done, you can unpause to check your work. So looking at 1, the first thing I would do is notice how many blocks I have there, not including the ones that are, blacked out. So in this case, in step 1, it looks like you have 8. In step 2, it looks like we have 10. And in step 3, we have 12. So just like we had before, I would make a table. So in stage 1 or step 1, we had 8. Step 2, whoops, we had 10. And step 3, it was 12. So just like before, you're going to look at the differences first. So 10 minus 8 is 2. 12 minus 10 is 2. So that means this is linear. And the recursive form and the explicit form. So the explicit is the easier one to find using your calculator. So you could plug this into your calculator. So just recall when you do that, stat, enter on edit, clear out your list, or you can hit delete on them. So I just need 1, 2, and 3. So I'm going to delete 4, 5, and 6. And then this is linear, so you go to stat, calculate, number 4, enter. And so we get A is 2 and B is 6. So A sub n equals 2n plus 6. So then for recursive, remember you state the first term, and the formula for the nth term is the previous term, plus your first difference, which in this case is 2. Okay, looking at the next one, same thing. So go ahead and pause the video and do this one on your own. When you're done, you can unpause to check your work. So of course, the first thing I would do is look at each of the different stages and how many terms we have in each, or blocks, I should say. So we have 1, 2, 3, 4 different pictures. In this first set, we have 7, then 12, 17, and 22. When you subtract each of these, you'll notice that this is actually linear again, which means that this pattern for recursive would be the first term is 7 and the nth term is equal to a sub n minus 1. And what are we doing each time? So 12 minus 7 is 5. 17 minus 12 is 5. So we're adding 5 each time. And the explicit form, again, you use your calculator. a sub n equals 5n plus 2. And that is all.